Welcome to 9.6, Solving Right Triangles. And what it means to solve a right triangle means that you have to find all the pieces using your trigonometric ratios. But first, we need to discuss how you actually get the angles if you've not been given the angles, and that's really what today's lesson is about. So this here is all kind of confusing, so I'd rather just show you with the problems how to do this, but I want to point out what this -1 here means. It just means the inverse of each of these. Inverse tangent, inverse sine, inverse cosine. You also could say arctangent, A-R-C-T-A-N, arc sine, it's the same thing, or arc cosine. Okay, so when you do that, you're working the variables, the decimals back that you took last week. So when you found the tangent of A, it gave you a fraction like BC over AC here, okay? And now what you're going to do is you're going to move the tangent to the other side. Just like if you had 2x equals 5, if you multiplied by 1/2, that's the same thing as dividing by 2, okay? Or we could just say 2/3 here. 2/3 x times or equals 5. You would multiply by the reciprocal, right? 3/2, and that would make it go away. You'd multiply it on both sides. The reciprocal is the inverse of 2/3. Okay, so in this equation, the inverse of tangent is tangent -1. If you take tangent -1 on both sides, that means you're taking the inverse. Okay, so when we do that, the tangent goes away, leaving angle A by itself. And what you have over here is the inverse of BC over AC. So you're taking the inverse. And how you get the inverse, you hit second tangent on your calculator. And that'll give you that little -1 on there. All right, so that's how you do it. And to solve a right triangle means you to find all the unknown side lengths and the angles. Okay, we just talked about that. All right, number 1. Determine which of the two acute angles has the given trigonometric ratio. All right, we want the cosine, and the angle is 4/5. All right, so which sides, when you write it as a fraction, give you 4/5? Well, if you're at angle A, you have 8/6, but that's tangent. So the cosine would be the adjacent leg. Cosine is equal to the adjacent leg over hypotenuse over 10. So that would be 6/10. Cosine of A is 6/10. That doesn't reduce to 4/5. All right. Now the cosine of C is going to be the adjacent leg, 8, over the hypotenuse, 10, which that reduces to 4/5. Okay, so determine which of the two acute angles has the given trigonometric ratio. That would be angle C. That's the answer. All right, now on number 2, we want the sine, and it needs to be 5/11. Well, here's 5 and 11. The sine is, remember, the opposite leg over the hypotenuse. Well, where's the hypotenuse? 11. All right, and how do you get the opposite leg? It's not going to be C, it'll be A. So the sine of A is equal to the opposite leg, 5, over the hypotenuse, 11. So angle A is that answer. Let's go a little bit faster. The sine, again, opposite leg over adjacent, is 0.96. All right, so now we don't know these decimals, so we're going to have to figure them out. So let's do, we know 24, well, let's just do 24/25. That's our hypotenuse. We'll do 7/25. Again, sine is the opposite leg over the hypotenuse. So we're not going to do tangent, which would be 7 and 24. Those are the opposite and adjacent legs. So you're going to bring up your calculator, and you're going to put in 24 divided by 25, and we get 0.96 right off the bat. All right, so what were those? That was these two values here, 24 and 25. Well, what gives it from what corner, either A or C, when we use the sine? So if you're not sure, do the sine of angle A and the sine of angle C. Sine of A gives us the opposite leg, 24, over the hypotenuse, 25. I don't need to do C because I've already found it. So angle A is the one they're talking about. All right, now the tangent. Tangent, again, is opposite over adjacent. So we're not going to be using our hypotenuse. So before I even begin, I'm just going to write them both down. Tangent of A is going to be the opposite leg, 12, over the adjacent leg, 18. And the tangent of angle C is the opposite leg, 18, over the adjacent leg, 12. Now it needs to be 1.5. Well, 12/18 is not bigger than 1, so I know right off the bat that this is the correct one. If you're not sure, then take 18 divided by 12 on your calculator, and you'll get 1.5. So angle C is the correct answer on number 4. Now, let D be an acute angle. Use technology to approximate the measure of angle D. So here's how you do this. I'm just going to do it down here at the beginning. The measure of angle D is equal to the arc sine of 0.75. So you hit the second key on your calculator. And if you're using your phone, you're just going to do, you have to put in 0.75 first. If you're using my calculator, you have to hit second sine first. So there's 2 different ways to do it, all right? So on your phone, you put 0.75 in and hit second sine. And that gives you the measure of angle D to be 48.6 degrees. All right, so that's what you're going to do on all of these. So on number 6, I'll do 0.19. I'll hit second sine of that, and that gives me 10. Oh, this is in radians. Sorry. Oh, no, it's degrees. All right, so let's do that again to make sure I'm right. 0.19, and inverse sine would be 10.95, or approximately 11 degrees. Okay, cosine, hit second cosine of 0.33, and we get 70.7 degrees. And the arc cosine of 0.64, that gives us 50.2 degrees. The arc tangent of 0.28 gives me 15.6 degrees. And the arc tangent of 0.72 gives me 35.8 degrees. Okay, now solve the right triangle. We need everything. They want absolutely everything. Okay, so we can use the Pythagorean theorem to get c squared. Okay, c, not c squared. So a squared plus b squared equals c squared. So 10 squared plus 24 squared equals c squared. So 10 squared is 100, and 24 squared is 576. So 676 equals c squared. So c, take the square root of 676, and we get 26. So right off the bat, we have that. All right, so now I'm not going to use that value in my calculations, even though I could. I'm just going to use these 2. So to get angle A, and I'm using the opposite leg and the adjacent leg, that's the tangent of A equals 24 over 10. To get the measure of angle A, I take the arc tangent of 24 divided by 10. So 24 divided by 10 is 2.4, and take the arc tangent of that, and we get the measure of angle A to be 67.4 degrees. And if we know that, then angle C is just 90 minus that. So the measure of angle C is 90 minus 67.4, which will get 22.6 degrees. Okay, so there are our 3 answers that we need. Now, number 12, we do the same thing again. This time I'm going to use trigonometry to get ED. I'm not going to use Pythagorean theorem. You can go ahead and use Pythagorean theorem if you want. So I'm going to get these angles first. Otherwise, I can't find the hypotenuse. So to get angle D, that's the opposite leg over adjacent again. So tangent of angle D is equal to 8 over 14. So the measure of angle D is equal to the arc tangent of 8/14. So 8 divided by 14 is 0.5714. I'll take the arc tangent of that, and that gives me angle D to be 29.7 degrees. Okay, subtract that from 90, you get 60.3 degrees for E. Now to get the hypotenuse, I'll use the 29.7 angle D, and those are the first two answers. So if I want the hypotenuse, and I use, let's say we use the opposite leg. So that's the sine of 29.7 equals the opposite leg over the hypotenuse. Now how do I solve for the hypotenuse? Multiply by h on both sides, and then divide off the sine of 29.7. So 8 divided by the sine of 29.7, which we already know the sine of 29.7. It's should be the same thing as 8/14 here. So the sine of, 8 divided by the sine of 29.7 equals 16.1. So just to show you this works, let's do Pythagorean theorem. 8 squared plus 14 squared equals c squared. So 64 plus 196 equals c squared. So 64 plus 196 is 260. Take the square root of both sides. So the square root of that is, look at that, 16.1. So there's multiple ways you can get your answers. All right, so now I'm just going to use the Pythagorean theorem to do to get b here. So a squared plus b squared equals c squared. So b squared equals 81 minus 9, which is going to be 72. Take the square root of that, and you get 8.5. All right, so again, I'm only going to use the ones that are exact, just in case I made a mistake. So to get angle Z, I'm going to use the opposite leg, and this is my hypotenuse. So that would be the sine of angle Z equals 3/9. So the measure of angle Z is equal to the arc sine. 3/9 reduces to 1/3. You could just do 3/9 if you want. So 1 divided by 3, and take the arc sine of that, and I get the measure of angle Z equals 19.5 degrees. Subtract that from 90, and we get the measure of angle X equals 70.5 degrees. So there's your three values. Do number 14. Again, this is B, so 14 squared plus B squared equals 16 squared. 256 minus 196, right? 16 squared minus 196 is 60. So b squared is equal to 60. Square root both sides, you get 7.7. So that's your first value. Now let's get J. J has opposite leg and hypotenuse, so I'll use sine again. Sine of angle J equals 14/16, or the arc sine equals, the arc sine of 14/16 is going to be the measure of angle J. So that is 14 divided by 16 is 0.875. Take the arc sine of that, and you get 61 degrees. And 90 minus that is going to give us 29 degrees. So the measure of angle G is 29 degrees. So there's all three of your values. Now we got 40 degrees. We don't have enough numbers to do the Pythagorean theorem, so now we have to do the values using trig to find these like you did on your test. Now, 90 minus 40 is 50, so now we have the measure of angle K. All right, so that part's done. Now we get X and Y. So from 40 degrees, I'm going to use the adjacent leg and the hypotenuse. So that's the cosine of 40. The adjacent leg over the hypotenuse, multiplied by 8. 8 times the cosine of 40 is going to give me X equals 6.1. And to get Y from 40, that's the opposite leg, and we're going to use the hypotenuse, so that's sine. Sine of 40 equals Y/8. Multiply by 8. So 8 times the sine of 40, and y is going to be 5.1. So there's your 3 values that you needed. Done with that one. Now number 16. So to get angle T, take 90 minus 57. And that should be 33 degrees. Okay, so the measure of angle T is 33 degrees. There's one of your values. Now from 57, we have the opposite leg. And let's go ahead and get the adjacent leg too. So opposite and adjacent is tangent. So the tangent of 57 is equal to the opposite leg over the adjacent leg. Got to remove the adjacent leg from the denominator. And then you're going to divide off the tangent of 57. So 15 divided by the tangent of 57. So on your calculator, make sure you put everything in correctly. And y is equal to 9.7. Now to get h from 57, you still use the opposite leg. And now you have the hypotenuse. So the sine of 57 is equal to the opposite leg, 15, over the hypotenuse. So multiply by h to get it out of the denominator, and then divide off the sine of 57. So 15 divided by sine of 57 is the hypotenuse, 17.9. So there's all 3 of those values. What did they do wrong here? Let's see, they did the sine, arc sine of 8/15, and they said that's angle T. So the sine of T is the opposite leg over hypotenuse, 8/17. Okay, so they chose the wrong value. This should have been the arctangent of 8/15. And that will give you the measure of angle T, all right, which is what? So 8 divided by 15, and we get 0.53 repeating, and take the arctangent of that, and the measure of angle T is actually going to be 28.1 degrees. In order to unload clay easily, the body of a dump truck must be elevated. So we're going to elevate the dump truck. Okay, so we got a right angle here. Elevate the dump truck to at least 45 degrees. 45 degrees. This is 90, and there's 45. The front of the body of the dump truck, that is 14 feet long, has been raised 8 feet. Okay, and so the front of the body of the dump truck is 14 feet long. So this is 14. It was raised 8 feet. Will the clay pour out easily? Okay. Okay, so what it's asking is, what is this actual angle? It needs to be raised to 45 degrees. All right, so here's what we have. We have a 14-foot long bed that gets raised 8 feet. Okay, so it's elevated, right? We don't know this degree here, x degrees. So once it's raised, we drop an altitude down. So we don't know this length right here. We do know this length is 14, the hypotenuse, because it got raised from this position. So, and it got raised 8 feet. So the right side here is 8 feet. So it wants to know, if it raised 8 feet, do we reach 45 degrees? Okay, so how do we find x? Well, from x, we have the opposite leg and the hypotenuse. So that's the sine of x equals 8/14. How do we get x? By moving sine to the other side. So the measure of angle x equals the arc sine of 8/14. So put that in your handy dandy calculator. And so we're going to take 8 divided by 14 is 0.5714. And we'll take the arc sine of that. So the measure of angle x is equal to 34.8 degrees. So no, it didn't raise it enough. Number 20, let's draw this triangle out here so we can see it a little bit better. That's 7. This is 12. You are standing on a footbridge that is 12 feet above a lake. You look down and see a duck in the water. What is the angle of elevation from the duck to where you are standing? So elevation goes up, remember, elevate. So here's the duck right here. So it wants to know again, that degree? Well, what positions do we have? We have the opposite leg and we have the adjacent leg. So that's tangent of x equals 12 over 7. So we need to get the measure of angle x by taking the arctangent of 12 over 7. So 12 divided by 7 is 1.71428, and then 29, excuse me. And we take the arctangent of that. So the measure of angle x is 59.7 degrees. That's the angle of elevation from the duck to you, because it's so important to know that. Not. The horizontal part of a step is called the tread. The vertical part is called the riser. The recommended riser to tread ratio is 7 to 11. All right, 7 being the riser and tread being 11. Find the value of x for stairs built using the recommended riser to tread ratio. Okay, so the tread is 7. All right, so, excuse me, the riser is 7. That's 7, 7, 7. So all that together, let's see here. You have those 3 7s, and you have 11, 11, and 11. But here, let's take this triangle out. This is 90 degrees. This is 7. That's 11. And we have this 2 parallel lines cut by this transversal. So alternate interior angles. So x degrees is going to be in that position. So how do I get x? Part A is find the value of x for stairs built using the recommended riser to tread ratio. Okay, so from this corner we get opposite over adjacent, that's tangent. So part A, tangent of x degrees is equal to 7 over 11. So the arctangent of 7/11ths. What do we get? 7 divided by 11 is 0.63 repeating. Take the arctangent of that, and we get 32.5 degrees. Now part B, you want to build stairs that are less steep than the stairs in part A. Give an example of a riser to tread ratio that you can use. Find the value of x for your stairs. Okay, so let's just say if we lower the riser and left the tread to be the same, okay, we could even make it longer. So let's say we have the riser being only 4 inches, and the tread we're going to increase to 12 inches. Okay, that's definitely going to make a longer degree, right? Or less degree. So again, alternate interior angles. So let's do the same problem again. So it's going to be the arctangent of what? 4 over 12, which is 1/3. So 1 divided by 3 is 0.3 repeating. Take the arctangent of that, and the degree is 18 degrees, 18.4. Okay, so that's just an example. You got to choose what you wanted to do with it, but you wanted your degree to be less. The Uniform Federal Accessibility Standards specify that a wheelchair ramp may not have an incline greater than 4.76 inches, or degrees, 4.76 degrees. All right, there's your incline. You want to build a ramp with a vertical rise of 8 inches. Okay, you want to minimize the horizontal distance taken up by the ramp. Draw a diagram showing the approximate dimensions of your ramp. All right, so it still has to be 4.76 degrees. So what it wants is, what is the minimum x can be, or what is the value of x? So what do we have from this corner? Opposite and adjacent. So the tangent of 4.76 degrees is equal to 8 over x. Well, multiply by x on both sides, and then divide off the tangent of 4.76, and that'll tell you what x can be. All right, so 8 divided by the tangent of 4.76. So that means 96.1 inches. Okay, so basically 8 feet. 8 feet is the minimum that this can be. Or excuse me, the maximum. If you do, or excuse me, the minimum. If you do less than 8 feet, let's say we made it to here, then obviously this degree here is going to be a lot bigger, and you can't have it bigger. You can go further out and have a less degree. So it has to be the horizontal part has to be at least 8 feet. 23 and 24, solve each triangle. All right, so they want us to solve everything. So that's 90. The measure of angle JKM, 90 minus 41 is 49 degrees. All right, 49 degrees. And we don't know the other angles yet. So let's do this one right here. Okay, so this is 41 and that's 9. Let's get y and the hypotenuse. So it's 2 problems in one, basically. So to get y, I can't use the hypotenuse because I don't know it. So I'll use the adjacent. Opposite and adjacent, that's tangent of 41 equals y over 9 multiplied by 9 on both sides. So 9 times the tangent of 41 is going to be 7.8. All right, so there's our first part, 7.8. Second part, sorry. So this is 49 degrees here. Now to get h, we're going to use, again, the adjacent side and hypotenuse. So adjacent hypotenuse would be cosine of 41 equals 9 over h. But h is in your denominator, you have to multiply it out first, and then you have to divide by the cosine of 41. So 9 divided by the cosine of 41 is 11.9. So that's the third part of that triangle. All right, so now we go to this triangle. We already have y. Y is 7.8. The hypotenuse is 21, so let's just use the hypotenuse, and we'll get x. And then we'll have to get these angles here. So now we have to use what y is to help us with our angles. So let's get angle L here. The measure of angle L is equal to, let's see here, opposite and hypotenuse would be a sine. So the arc sine to get our degree is 7.8 over 21. So 7.8 divided by 21, and take the arc sine of that, and you get 21.8 degrees. So therefore, the measure of angle LKM is going to be 90 minus that, so 68.2 degrees. All right, so there's those two, but now we got to get x. So we can get x by putting the 21.8 degrees right here and using the adjacent leg and the hypotenuse. So the cosine is the adjacent leg over hypotenuse. The cosine of 21.8 is equal to the adjacent leg over 21, multiplied by 21 on both sides. So 21 times the cosine of 21.8, and that gives me 19.5. And that's x. So we solved all the pieces of the triangle using trig. And TUS, triangle TUS, let's go ahead and just drop this over here. So this is 4, this is 64. So 90 minus 64 would be 26 degrees. Hypotenuse, and we're going to use this angle here, S, to get x. So that's the opposite leg and adjacent leg, so the tangent of 64 is equal to x over 4 multiplied by 4. So x is equal to the tangent of 64 times 4. So 8.2. Let's check that again. Tangent of 64 times 4 is 8.2. Okay, just 8.2 here. And then we need TS, the hypotenuse. So we're going to use the adjacent leg and the hypotenuse. So that is going to be the cosine of 64 is equal to 4 over the hypotenuse. So multiply by the hypotenuse and then divide by the cosine of 64. All right, so 4 divided by, be careful putting this into your calculator. 4 divided by cosine of 64 equals 9.12 or 9.1. All right, so that's the left triangle. Now to do the right triangle, that's 9. And 5 millimeters is this piece right here. So 5, and we found the hypotenuse here of 9.1. So the hypotenuse is 14.1. Okay, so if we want to get V, we're going to use the adjacent leg and hypotenuse. And since we're getting angles, it's the arc sine, arc cosine. So adjacent leg and hypotenuse would be the arc cosine of 9 over 14.1. So the measure of angle V equals 9 divided by 14.1, and the arc cosine is 50.3 degrees. Subtract that from 90, you get 39.7, and that's the measure of angle, it'd be VTW. But then we got to get this little piece over here. We'll call this little t. So from V, that's the opposite leg, and we'll use the adjacent leg here. So the tangent of V, 50.3, is equal to the opposite leg, t, over the adjacent leg, 9. Multiplied by 9. And so t is going to be, 50.3, the tangent of that, let's clear that, 50.3. Tangent of 50.3 is 1.2045 times 9. So that's 10.8. So there are all your pieces of the puzzle. And that's it for your assignment.